Hello there. Welcome or welcome back. Um, our new subject is going to be position and warning systems. A little bit of a catch all category, but the FAA has directed us with the type of questions that they ask in this category, so that's the type of material we're going to cover. We're going to start with landing gear warnings. Um, Looks like I have a subtitle here, position indicating lights, um, and that's measuring instruments for the mechanical movement of various aircraft components. The most common that we're going to see, and the most common that have faults, are the landing gear lights. They don't always light up correctly with what the gear is doing. It's a frequent problem, and the more you deal with it, the much better you'll get at troubleshooting and determining uh, if there's a fault. But right as you can see on the screen, uh, this is a tricycle style aircraft, and the single nose gear up front is illuminated in green, and then both the main landing gear, the right and the left, are also both illuminated. And their placement on the board is similar to its is the same orientation as their placement on the ground. Um, Certainly, if the nose gear is down and locked, it's going to be safe to land. So, if all of a sudden one of the lights is not illuminated, you can imagine the pilots are going to talk to you about it. And it could just be a light bulb out. Um, so basically, they just want to know whether or not it is configured, it's in the right configuration. They need to know whether or not the landing gear is down and locked or if it's not down and locked. If the cabin door is closed and locked or if it's not closed and locked. This information can be generated and displayed by simple switches and lights. So we see the lights. Maybe the next screen we'll see a switch, more than likely a micro switch. Yes, or a precision switch, which has the trade name micro switch. Um, and it's you can see the mechanism of how it works. It has points or contacts that'll either come into contact or it won't. As you can see, if this was a long pipe and you push it down, it's going to separate the points. And if all of a sudden the plunger is retracted, then the spring mechanism here, is going to force the contacts back together. So we would call that a normally closed switch because you have to actually have take some motion in order to open the switch. They're used primarily as limit switches. So basically, if the operating plunger is placed precisely on the landing gear, it can determine its position and illuminate a light in the cockpit. We can look at the FARs. Here's 23. Um, if you have retractable landing gear, so the aircraft that do not have retractable landing gear, their landing gear is always down and locked. But if it's retractable, there must be a landing gear position indicator as well as necessary switches to actuate the indicator or other means to inform the pilot that each gear is secured in the extended or retracted position. If switches are used, they must be located and coupled to the landing gear mechanical system in a manner that prevents an erroneous indication of either down and locked, or if each gear is not in the fully extended position. All right, I probably should have stopped at the first sentence. Just do not erroneously place the switches, I believe, is what the second longer sentence is talking about. Certainly don't place them in a manner where it could actually give a false indication. But basically, there must be is the words that we're looking at. There must be a landing gear position indicator. All right, here's in the case of this aircraft that has flotations or floats attached to them, there's actually going to be two nose gears, one in each of the pontoons in effect, and then the main landing gear, which is also contained in the floats themselves. And you will see lights come on for when it's when you toggle the switch up, the big switch here. Each one will, left nose locked, right nose, left main, right main. And you know that they're up and locked in the up position. Then you push it down, and you'll get the same indication on the bottom ones. Nice thing about these is that you can quickly check the light by finding one that is actually is working, and then just pull it out and substitute. But it's often going to be in the alignment of the micro switch. I believe this type uses magnets, so that they do come out of alignment with each other. Here's a simplified diagram of a position indicating system that turns on a light only when all the three landing gears are down and locked. So this one doesn't have the three lights. It just has one light, and it's going to indicate whether all three. So basically, this electrical signal is going to run through the three micro switches on the right, the left, and the nose gear. And so if they're all closed, you're going to get a complete circuit ground, and it's going to illuminate the light, indicating that the gear is down and locked. And now, if you may have already covered AND gates and OR gates, basically this is an AND gate. It looks like a boat. So basically all three inputs have to be positive in order to get a positive result, or which would light a light. And so you can run it through an electronic component like an AND gate or a series of components. A typical question. Microswitches are used primarily as limit switches to A. Limit generator output, B. Control electrical units automatically, or C. Prevent overcharging of a battery. Okay, microswitches, I suppose, well, clearly B is the clear runner. I might have phrased it a little differently, but it's definitely not used for batteries or generators. So it's going to be to either measure electrical units or to control electrical units automatically. And they use an example here, such as the electrical units as flap and landing gear actuator motors. So the flaps would also have indicators to let the pilot know whether or not the flaps are extended or not. I'm not sure if there's an FAR that covers that. There likely is. If it is, I'll have it here. Which repair would require a landing gear retraction test? So when do you have to actually jack up the aircraft and run, retract, and extend and retract, uh, uh, lower and retract, and I guess what do I call that? Extend, retraction, and extension test. Um, A, landing gear safety switch. B, red warning light bulb. Or C, gear down lock micro switch. So when would you require a landing gear retraction test? To make sure that everything is working. Probably if you change the actual micro switch, you're going to want to make sure that the micro switch operates and actually illuminates the correct bulb in the cockpit. So without doing too much overthought on the other two, certainly a light bulb wouldn't be it. The landing gear safety switch, which is kind of known as the squat switch, that senses a different position of the landing gear. That is not the switch that would determine. You'd probably have to do if you're going to work on that switch also. I can definitely see you needing a landing gear retraction test just to verify the operation of that switch. But that's basically weight on the wheels, so that's whether or not it extends, which is different than having your landing gear locked up or locked down. So I'm going with C, and probably a long-winded way of getting to it. Well, C is the correct answer. I would probably give partial points, but this is an FAA exam, and basically you have to answer it the way you want to answer it, and you'd want full credit anyway instead of partial credit. Landing gear warning systems usually provide which of the following indications? A, red light for unsafe gear, no light for gear down, and green light for gear up. So I guess we're going to have to think about this one a little bit. The options are going to be gear up, gear down, and unsafe gear. Well, certainly red for unsafe gear. But that's A and C. So what else do we have? Gear down or gear up. So where would the no light? Probably the no light would be if your gear is up. The one with the floats I showed you does continue to illuminate the lights while the gear is up. I suppose for long flights, that's going to wear on the bulb life compared to the down and locked, which are only on until the master switch is turned off. So that would be C, isn't it? Yes. Green if your gear's down, because that's what's important. You want to know that if you're landing. The gear up, that's mostly just more for convenience, and you certainly don't want to be flying with your gear down. So it is C. All right, here's a FAR. What's this going to be about? For land planes, the following devices must be provided. So I guess a seaplane wouldn't have to worry about these. Um, a device that functions continuously when one or more throttles are closed beyond the power settings normally used for landing approach. All right, and this is going to get into some of the schematics that you will be tested on. And its basis is in this FAR. So basically, it's going to be tied to the throttle. So the aircraft's going to do a few things that are a little smarter than just leaving it to rote sequencing. So basically, um, if you're going to close the throttle, so basically you're lowering. In order to normally land, you're going to pull back on the throttle a little bit. You're going to retard the throttle or close the throttle according to this here. So if you if the landing gear is not fully extended and locked, basically there's going to be some sort of warning. So all of a sudden you're pulling back on the throttle like to land, but the plane knows that the gear isn't down and locked. It's going to illuminate a light, and I believe in most of the systems that we're working with, it also illuminates or it sounds a horn. All right, that's going to be good enough. Once you work through the diagrams, and it looks like 2 also talks about the flaps. So if you're going to land, you're going to be extending or lowering your flaps. So it's going to measure that. And if you're doing that and the landing gear is not fully extended and locked, there could also be a warning, but you can turn that warning off. All right, here's the horn. I said horn, I guess oral warning devices. A steady warning horn, okay, is provided to alert the pilot that the airplane is in a landing configuration and the gear is not down and locked. So you're doing something. You're extending the flaps, or you're pulling back on the throttle, but your landing gear isn't down. So it is dependent on the flap and the thrust lever position, or your throttle. All right, what landing gear warning devices is or are incorporated on retractable landing gear aircraft? All right, we just took a peek at the regulation. Which of the 3 is it? And keep in mind, professors are free to add more options. My belief is that these are going to be the official questions that you're faced with, and in order to get you even better at it, maybe throwing in another false option might disguise the question a little better. Mix up the option order, A, B, and C, and all of a sudden the question does look different. So if you memorize a certain answer, it's going to look a little different when you actually get to the test itself. All right, so we got retractable landing gear. What type of gear warning devices are there? A visual indicator showing gear position. B, a light which comes on when the gear is fully down and locked. So far, I guess that one's good. Or C, a horn or other oral device and a red warning light. All right, so B, sounds right, but it's not exactly up to the level of the landing gear warning devices. That was certainly landing gear position, but then the last regulation we looked at, we want you to be warned if you're doing something wrong. So the way we warn you is with a horn and a red warning light. Which of the following conditions is most likely to cause the landing gear warning system to sound? Well, when do you think you're going to hear that horn? Is it when the landing gear is locked down and the throttle is advanced? Or the landing gear is locked down and the throttle is retarded? I think the landing gear is going to mostly warn you if the landing gear is not locked down. So in this case, we only have option C. Feel free to assume that if it were me, I'd add D of landing gear not locked down, and the throttle advanced, which is also incorrect. But C is the correct answer. Landing gear is not locked down, and one or more throttles are retarded or closed. I suppose it would be when we correct the language. So that is the correct language. All right, here's one of the figures. What is the minimum circumstances that will cause the landing gear warning horn to indicate an unsafe condition? Now this one here, you don't even really need to work through the diagram. This one here, you can just know it from the last question. All gears up and one throttle retarded? That's possible. Your gear's up, but you're pulling back on one of the throttles? I think you might get a little alert there. B, any gear up and both throttles retarded? Well, I suppose that would work also. I guess we're going to have to see which one's the minimum. Or C, any gear not down and locked and one throttle retarded. All right, so I guess I kind of jumped on this any gear up and thinking we really only get the warning when it's not down and locked. If it's up, it's not going to be down and locked. I like the fact that they're using, instead of any gear up, any gear not down and locked, because it could be halfway between up and down. It got stuck in the middle. So any gear not down and locked and one throttle retarded would be the correct answer. I think there's going to be another question about it. Let me see. I thought I had a separate. All right. Apparently, I end there. Although I've got some supplemental questions. I put this one together quite a long time ago. So let me see if I can look through the diagram here. I might have to move my camera to do that. Um, I think I have this in an. I go through a little more detail in another spot, so I'll come back to that. That one we didn't really need the figure anyway. You can answer that one just by reading the options. Um, let's take a look. Apparently, I have some my oral questions. I don't have them placed um, in the specific topic, but let's see what we have. What devices are used to provide warnings for retractable landing gear system? Um, well, I believe they're talking about the oral device like a horn and the illuminating device like the red bulb, I believe. A horn, yes, that's it exactly. How can a pilot determine that the landing gear is down and locked? Yeah, it's too bad. The some you actually have a little view that it is possible to actually visually verify, but that is very limited. You're not going to see much, and if it's dark, I mean, I suppose it could be illuminated, but how would you normally tell that the landing gear is down and locked? And with the floats, which was nice because in addition to the light, there was also a little green arrow, a little green um, piece of metal that would cover a hole, so you can actually look out and see green. Getting off the point, how can a pilot determine that the landing gear is down and locked? Well, certainly uh, the light in the cockpit, the position light, should indicate that. How can you verify it is if the light isn't illuminated? I'm going to go with the light. Okay. A green light or lights or another type of visual indicator. What landing gear positions must be indicated by regulations? Um, so the landing gear positions, we certainly know that when it is down and locked. How about up and locked? Oh, and then how about in transit? Most will kind of tell you all three, but what does the regulations require? Certainly down and locked. All right. Um, obviously, I gave the three options. I don't. I went through regulations just now, but down and locked. And up and locked. All right. I'd go back and take another look at the regulation. Under what conditions will a landing gear oral warning sound? A very similar answer to the correct option in the multiple choice, and that was any gear not down and locked with any throttle retarded. I like the words any in there. They don't use them. They just say the throttle, the landing gear. What systems are commonly used to activate the landing gear warning systems? Commonly used to activate the warning systems. All right, that was certainly the landing gear uh, is not down and locked. They also measure the throttle, whether or not you are retarding or advancing a throttle. And they also have, we saw, looked at the flaps to see if the flaps are extended while you're retarding a throttle without the landing gear down and locked. I don't believe any of the other flight surfaces, like ailerons, rudder, or elevator. So I'm going to go with just the three I already listed: the throttles and the wing flaps. All right, the landing gear also. At what time would a check of the landing gear warning systems normally be made? Um, Certainly, if they went off um, during any time that you are service, anytime you have you're doing a retraction test, and so anytime you have the aircraft jacked, you certainly would check it to make sure that it is warning. Yeah, during the landing gear retraction test. If an aircraft with retractable landing gear has only one green light to indicate the gear is down and locked, how will the switches be connected, in series or in parallel? That goes back to our one green light, and we did see that in order to do that, there was also a figure 20. It has to go through all three switches in series, which was the bottom part of figure 20. I'll cover figure 20. That's one thing. These figure 19 and 20 that have the schematics, that bounces around a little bit between this and electrical. So I think there's only a couple questions other than oral questions about this in position and warning. So I'm going to presume that it's going to be an aircraft electrical. Where would you locate the procedures for checking and adjusting the landing gear switches? Well, there would, in the case of the floats, they were in the whip line service manuals. But in the case of just a general land plane, I would imagine it's in the manufacturer's maintenance manual. Couldn't think any place else that it would attach. Aircraft manufacturer's manual. Sometimes these new questions have been adopted, so be aware of these new ones. What is used to monitor the position of each gear during all flight operations? And that one we already saw. It's like the position isn't exactly the squat switch. The squat switch is the weight on wheels. So what do we call the micro switches or the precision switches when those are not there? Do we call it an indicator switch or a limit switch? I believe the third reference of these switches is limit switches. So it is a series of limit switches. A limit switch is simply a spring-loaded momentary contact switch that is activated when a gear reaches its limit of travel. It might be because it sounds like the way it's described, it would be a normally off switch, and it is only activated. The switch is only closed, or it's a normally open switch. Because in order to close the switch, you have to travel to that point. So that might be what a limit switch is. It's the same as a micro switch or a precision switch, but it is activated and not um, in effect, deactivated by a movement. The switch that prevents certain operations when the weight of the aircraft is on the landing gear, that one is the trick there is the weight of the aircraft. So that'll prevent certain operations such as, well, I would say anti-skid, which is also part of position and warning, but we'll cover that in more detail when we get to it. That is either the squat switch or the weight on wheels, WOW switch, but the squat switch, or sometimes I'll call it the ground. I think figure 19 doesn't refer to it as a squat switch, but it talks about the ground safety switch. But for this purpose, it's going to be the squat switch, even though I do see A does have the word ground in it, but it doesn't have the word safety. So sticking with B. And obviously, that's what the manufacturer or the publisher of the book also thought. All right, I guess that's going to conclude it. I appreciate you hanging with me, and please join me on the next one. All right, see you later.